So today we're going to multiply decimals. So I have on the board 4 pretty similar problems, but they're going to take us to 4 very different answers. Does anybody have a memory of multiplying with decimals from your earlier life days? Anybody remember how this went? So multiply, you don't need to line anything up. Okay, so adding and subtracting, everything had to get lined up. Multiplying, the first thing you do is multiply, just like decimals have never been invented in life. Okay, so all of these problems I would just look at as 3 times 4 kind of stuff to begin with. So all of these answers have something to do with
3 times 4.
which makes 12. All of these answers are going to have 12s in them. So that's your first move, is just multiply like no one ever heard of decimals before, just multiply the numbers. Then there's a trick to know, or a rule, I don't know if it's really a trick, but there's a rule as to where the decimal needs to be. All of these answers are going to have decimals in different places. Maybe it's after the 12, maybe it's in the middle, maybe it's before the 1, maybe it's way over here to create some empty spaces. But there's some sort of way we know where the decimal goes. Does anybody remember how that was, now that we're a little bit started?
Like where the decimal is on the back column? I don't know.
So what we're going to do is we're going to count all the decimal places which have to be on the right of the decimals in the problem. So any number that's on the right of a decimal point counts. So how many numbers here count?
2, 1.
1. Which one?
The 3 and 4, or the 3.
The 3. The 3 is on the right of a decimal, so the 3 counts. We count 1. This doesn't have any decimals, so that doesn't count. Over here, how many of these numbers count? 2. Who counts?
3.
The 3 and the 4 are both on the right of decimals. So we have a count here of 2. This had a count of 1. What's this have a count of? Just yell. 4. 0, 3, 0, 4, all that stuff. All 4 of them are on the right. We need to make a count of 4. This has the biggest count. This has a count of
7.
7. So what we do, we look at the problem, we count how much stuff is on the right. Then we need to make the answer have the same count. Okay, so this, to make a count of 1, where would I put the decimal in this number to make there be a count of 1?
Before the 1.
You mean here or you mean there?
Right before,
Here?
Yeah.
Disagree there. If we put the decimal right here, how much is our count? 2. Everything to the right counts. So we need to plot the decimal so that there's 1 number to the right. Where are we going to plot it? What do you think?
In between 1 and 2.
Right in between. So if we go there, then we're counting 1 number. The problem counted 1 number, the answer counts 1 number. Here we decided the count was 2. So where can we throw the decimal in this to make a count of 2?
Before 1.
You're right at the very beginning. If we put it there, we've got a count of 2. Here we need to make a count of 4. That's kind of weird. How can we make it possible to even do that? We need to add 2 zeros before the 1 is correct. If you don't have enough stuff, add zeros before it even gets started. And then where's the decimal?
Before the 0.
All the way to the beginning. So this, to make a count of 7, what do we need to even have that much stuff?
You need to add 7 zeros.
No, not 7 zeros.
5.
5 zeros. Why 5 zeros?
Because there's the 12 already.
We already have the 12 as 2 of our numbers we're going to use. Then we need 5 more zeros. 1, 2, 3, 4. 5 more zeros to get up to 7. And then where's the decimal dropping?
After the last 0, or before the last 0.
Before that, before everything starts. Quick thing I would adjust about that answer, but before I do the adjustment, anybody confused? Anybody want me to re-explain?
No, it's pretty easy.
Okay, let's go one more round just to be safe. Quick adjustment. If I wrote you this number, you'd be right to criticize me. If you wrote that number on a test, I'd be right to criticize you. What would be more helpful if I did to that number, you did, we did to that number?
Turn it into just one.
No. What is that number?
1 million.
That's 1 million. How could I write that in like a better, more readable, understandable way? What could be done to improve this answer? No?
Commas.
Commas would be my friend. So how do you count commas when you get these big monster numbers?
3 0, like you put comma between, like 3 zeros, comma, 3 zeros, comma.
Yeah, you start from the
Uh,
right side or the left side to do our
Right.
Start from the right. So we start from the right, go 3 spaces, comma, 3 spaces, comma. That's more readable as 1 million, since it's 1 comma, it's a little clearer, it's 1 million without having to sit there and count. Decimal numbers that get lengthy don't do commas, but what is used for these is to put a space in. Though, people that do math long numbers like this will go 3 zeros, leave a space, go the other more zeros, and then finish with the 12. It's a little bit easier to look at this and know that there's 5 zeros than to look at this and have to go 1, 2, 3, 4, 5. You can pretty clearly see there's a group of 2, a group of 3. It just, there's 6 of them there. It's a thing called sight counting. Like if I said to you, how many dots are there? It's sort of annoying. You have to count them, you can do it, there's 6. If I went like this and said how many dots are there, it's a little clearer that it's 6 because I did them in groups of 3. That's what they're doing here for us. They're just gonna do the zeros in groups of 3, put little spaces in so that we can sight count them instead of 1, 2, 3, 4, 5, 6 count them. It's not a huge deal there. But if I had to deal with that number, I'd be kind of grouchy if I had to sit there and like count all those zeros. Okay, that's a much more readable number if I go 000, 000, 000, 007. I can very quickly tell you there's 11 zeros in this one without having to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 zeros in that one. So, question about the main theme? We'll go one more round. Go 0.7 times 4, 0.7 times 0.4, 0.007 times a regular 4, 0.00007 times 0.00004. All of these answers have something to do with
28.
28. 7 times 4 is 28. This one has the lowest count. The count is only 1. So make the answer have a count of 1 by dropping the decimal in right in between them. This has a count of 2. So we drop the decimal in
The beginning.
the very beginning. This has a count of
4,
5.
3.
3. 1, 2, 3. We're only going to count stuff that's on the right of decimals. Crash. This doesn't count. If you want to make a count of 3, how do we do that? Because I don't have 3 yet.
You add an extra 0.
On which side?
The left side.
Left side is where we add the zeros, the decimal
At the beginning of
way
the
at the beginning of it. Last one, big count.
8.
Recount.
Wait, 9.
Recount.
11.
11. 3, 6, 9, 10, 11. All 11 of those numbers count. So if we're going to try to get ourselves 11 positions, we need a decimal and then 11 positions. How are we going to create 11 positions worth? 9 zeros. So I go 000, space, 000, space, 000, space, 28, 9 zeros. There we go. Question about that? So we're going to do the same thing we did yesterday, just with a littler paper. I have, I don't know, maybe 6 or 7 problems on this. try them. When you're done with all of them, give me a yell. We'll make you get them all right. As soon as you get them all right, I'll talk to you about what the homework is going to be.